In section 6.4, we will look at special parallelograms. Each diagonal of a rhombus bisects two angles of the rhombus. So remember, the word bisects means cuts in half. The diagonals of a rhombus are perpendicular, so that means we have right angles in our center. The diagonals of a rectangle are congruent, so we can say that AD is congruent to BC, or they are equal. They have the same measure. If one diagonal of a parallelogram bisects two angles of the parallelogram, then the parallelogram is a rhombus. If the diagonals of a parallelogram are perpendicular, then the parallelogram is a rhombus. And if the diagonals of a parallelogram are congruent, then the parallelogram is a rectangle. So this is just reversing our definitions and saying that they still hold true. Let's look at some examples of finding the angle measures of the rhombuses, which is plural for rhombus, or you could say rhombi. In number 1, we have that angle N is 120 degrees. And we just learned that the diagonals of a rhombus bisect the angles. So that means angle 1, angle 2, 3, and 4 are all congruent. We also see we have a triangle MNP, which we know those angles add up to 180 degrees. So, to find angle 1 and 3, since they are the same, if I take 180, subtract the 120 that I know, I get 60 degrees. So I'm left with 60 degrees for two angles. So if I divide by 2, I get 30. So that tells me angle 1 is 30 degrees. Angle 2 is 30 degrees. Angle 3 is 30 degrees. And angle 4 is 30 degrees because they are all congruent. Okay, in number 2, we are given one of our angles of 50 degrees. Well, we know that the diagonals are perpendicular, so I know right away that angle 1 is 90 degrees. And then we'll fill in our other missing angles in a minute. Oops. Fix that angle. Okay, so I'm going to go ahead and mark my diagram. So we know angle 1's 90, so this angle's 90, so is this one and this one. I also know that the diagonals bisect the angles, so these 4 angles are congruent. So that makes angle 2 50 degrees and angle 3 50 degrees. Well, angle 4 is part of the triangle in the bottom, so to find angle 4, I'm going to take 180 minus 90 minus 50. Those are the two angles that I do know, and I get 40. So angle 4 is 40 degrees. Okay. All right, now number 3. Okay, so I'll list out the angles that we're going to find. Now, we don't always necessarily find them in numerical order. Like right away I can tell angle 2 is 90 degrees because our diagonals are perpendicular, so these center angles are all 90. All right, and also these 4 angles are congruent because the diagonals bisect each other. So I know angle 1 is 78 degrees and angle 4 is 78 degrees. Now if I want to find angle 3, we see it's part of a triangle. So I can take 180 minus 90 and minus 78, and I get 12. So angle 3 is 12 degrees. Now let's look at two examples with rectangles. Number 4 says one diagonal of a rectangle has length 8x plus 2. The other diagonal has length 5x plus 11. Find the length of each diagonal. Okay, so we learned that the diagonals of a rectangle are congruent. So I'm going to make an equation where my two angles are equal to each other. So 8x plus 2 equals 5x plus 11. All right, now I want to get my x's on one side, so if I subtract 5x, I get 3x plus 2 equals 11. Then subtract that 2. 3x equals 9, so x is 3. Now I'm asked to find the length of each diagonal. Since they are congruent, it does not matter which expression I substitute in for. I'm going to choose the second one. So 5 times 3 plus 11. I get 15 plus 11, or 26. So each of my diagonals have a length of 26. And number 5, find the length of FD in rectangle GFED. So we know FD is 2y plus 4. GE is 6y minus 5. Again, the diagonals are congruent, so we're just going to set those two equal to each other. So 2y plus 4 equals 6y minus 5. Subtract our 2y. So 4 equals 4y minus 5. Add 5. 9 equals 4y. So that means y is 9/4, or 2.25. You can put the decimal here because it's a decimal that terminates. All right, so FD will be 2 times 9/4 plus 4. So we get 8.5, or 8.5. Okay, in our last examples, we are going to determine whether the parallelogram is a rhombus, rectangle, or neither. And we would choose the option neither if we do not have enough information. On number 6, so we know that the diagonal is bisecting the angles. We have congruent angles. So number 6 is a rhombus. And that's because the diagonals bisect the angles. On number 7, we're told AC is congruent to BD, so meaning our diagonals are congruent. So this is a rectangle. 8, a quadrilateral with angle measures of 30 degrees, 150 degrees, 30 degrees, and 150. So if we just draw a quadrilateral, 30, 150, 30, 150. Okay, so we know our opposite angles are congruent, but we do not know anything about our diagonals or our sides. So 8 is going to be a neither. We don't have enough information, so we know it's a parallelogram, but we don't know if it's a rhombus or a rectangle. And finally 9, the diagonals of A, B, C, D are perpendicular. Okay, so we know we have 90-degree angles in the center. Let's mark A, B, C, D. AB is 16 and BC is 8. Okay, well, it's not a rhombus because a rhombus has 4 congruent sides. Could be a rectangle, but we don't know about the other sides if they're congruent or not. Remember, in a rectangle, opposite sides are congruent. So again, we're going to say neither, just not enough information on that one. You know, it's a parallelogram, but we don't know if it would be a rectangle or not.